Good morning, sir.
Good morning. So very good morning to all of you. Good morning, Pratik. Good morning, Shashank. Good morning, all. So today we are going to discuss the next topic, which is we can say model evaluation and model selection. These two topics are very important. The previous lecture we have already discussed about the subset feature selection, which is based on three methods. The first one was filtering, then wrapping, and then embedded. So we discuss all that methods. I will also share the coding of that thing also. But today we are going to discuss the next topic of machine learning. It is very important, and the subtopics I think you know the subtopics name also. So we will discuss one by one. Let's see. So today, mainly the basic topic we are going to discuss is model selection. So model selection, it means when we are going to design a model or machine learning algorithm. So that is first question is that on what basis and how we can select the perfect model for our target value or to achieve the target, and how we can evaluate that model, that what is the performance of it, and what are the criteria that it is the best model for my target value achieving. So that things we will discuss in this lecture. So we already done the feature ranking and subset selection, then filtering, wrapper, embedded methods. So today we are discussing evaluating machine learning algorithms or models and model selection. So how we can select the model and how we can evaluate it, that we are going to discuss today. So let me start. Please listen concentrately, and if you have any question, then ask during the explanation. The first thing is model selection and model evaluation. So what is the model evaluation? So in simply we can say it is a method of assessing the correctness of the model on the test data. So model evaluation, it means suppose we have a test data. In the case of supervised learning, we can say like that. So we build the model and we apply the test data. And what is the test data? The data which is never seen before by the model, that is known as the test data. So we apply the test data on the model and we check the evaluated value and targeted value and compare the error between them, and then we can say the model is well suited for us or not. Okay. Then the test data consists of the data points that have not been seen. So what is the test data? The data which is still not applied on the model. So that is simply known as a test data. So then the next thing is how we can select the model. Evaluation, we can also need to evaluate the model. But before evaluation, we need to select the model. Then how we can select the model? So it is the techniques for selecting the best model after the individual model are evaluated based on the required criteria. So suppose for a particular problem, we evaluate one or three different parameters. We test the data on the different models, and we category the result of that evaluated model, and among them how we can select a best model. So that is known as a selection. Selection is nothing but among the evaluated model, which model will be selected for generating the target value. So that is known as a simply model selection. So first of all, today we are going to discuss model selection, and then some topics of model evaluation. So let me start. So it is taken from one of the ML site, that is a Vidya Analytics. So I taken it from there. It is I think it is very good diagram to explain the things. So model selection is mainly based on two methods. Good morning, Mohit. The first thing is probabilistic, and the second thing is resampling. So both two things are used for model selection. So what is the model selection? On the basis of evaluation, we do the evaluation, and then the result of evaluation, we will choose the model by comparing the evaluation to each other. Then there are two things, the resampling and probabilistic, and the one thing is random train or random test. Sorry. Okay, sorry about the disturbance. So, so we are going to discuss what is the k-fold, simplified k-fold, and in the probabilistic we will discuss EIC, BIC, and MDL. So today we mainly discuss these two methods and one of these methods. So first of all, we need to discuss what is the resampling, and we can say what is the probabilistic. So in the one case, we simply take the performance of the model, and in another case we take the performance as well as the complexity of the model. So in the case of probabilistic, we consider not only the performance of the model, but we also consider the complexity of the model. For example, suppose there is a linear regression, so complexity is very less, and suppose we are discussing about the ANN, artificial neural network. So in that network, complexity is very large. So we consider the both things, because if the performance is very good but complexity is very high, then it also we have limitation on that. But if the performance is low and complexity is also low, then we consider it something like that. So probabilistic contain both complexity and the performance, but consider the both complexity and the performance during the selection of the model. But in the case of resampling, it is considered only the performance of the model. So model selection, we can say resampling. So the first method is k-fold or k-fold cross validation. So k-fold cross validation is very popular method or model. It is very we can say this is the very interesting topic that asked by the so many companies during the interview of the for the job. So it is very important topic. We will also discuss the Python code of it in the upcoming classes. So when we're discussing the k-fold cross validation, in this k-fold cross validation, we have the whole data set, and that whole data set is divided into some k folds. K is any value, integer value like 5, 10, something like that. And during it is the iterative process. In this first iteration, we take a first set of data, which is simply known as a training data, and rest is known as a test data. Okay, training data, it means we train the model on the basis of that test data and training data, and after training we test the model with the remaining data. In the next iteration, we takes next subset, and rest of the data is work as a test data, and next subset is work as a, we can say, training data. So I just explain you with the help of this diagram. So this diagram show the basic concept of this. So it is the first selection of it. It is simply known as, it is our whole data. It is our whole data in the, we can say, this model selection. So it is a test data, and it is a training data. Okay, so test data. So we first of all we define some k folds. So we have, for example, 1, 2, 3, 4 k fold. We simply define like that. And that we in each fold we divide the data. First we take one subset. Suppose we take one subset, like this subset is taken. So we have iteration 1 fold, 2 fold, 3 fold, and up to k iterations. So k fold we take, k iteration we takes. So we take a one subset, and it is work as a test data, and rest is known as a training data. Okay, so I told you that we train the data with particular data set, and then we apply the test. The remaining data is applied for the test to check the model accuracy. Again, it is a test data, and rest is used for the training. Again, it is a test data, and rest is used for training, something like that. And you can say, if you select the subset, that is for the training, and rest data for the test data. So you can also say like that. So in the k fold cross method, we simply iteratively do, or we can resample. Resample, it means we change the sample for the test as well as the validation. That's why it is come under the resampling. Resampling, it means the sample is changing. That's why it is known as the resampling method. So let's read out the concept. So the cross validation techniques works by randomly shuffling the data set and the splitting into the k groups. So we're splitting data into the k groups and we're randomly shuffling the data set. It means we change the value of data of test data and we change the value of trained data. Thereafter, on the iterating over each group, iterating one by one iteration we apply, the groups needs to be considered as a test set while the other groups is combined together an iterative set, training set. So here the one set is considered as a, this set is considered as a test set, test data, and rest is simply known as a training data set. Okay, then thus the model is tested on the test group and then process continue for the k groups. So the model is simply tested on this particular test group. We train with the remaining data and we test with particular test data, and this process will continuously up to the k iterations, and this is known as a resampling because the test data and training data will change in each iteration. That's why it is known comes under the resampling. By the end of this process, one has k different results. So at the end, we have a k result different because we take different k test set, or in the k test set we have in the k iterations. So the number of test sets and number of iterations are same generally because in each iteration we take the new k set for the test to the our model. So this particular test data is generate the one result, then another next result, then next result, then we have total k different result value. So by the end of this process, one k different result on the k different test groups. So the best model can be selected easily by choosing the one to the highest score. Highest score is simply means we already discussed how we can assign the rank and score, something like that. So score is difference in simply explaining the correlativity of the data to the, or we can say selected data with the, we can say target value. So higher score rate means higher probability to cover the whole data to represent the particular target value or to produce the particular target value. So how it work in the k folds, we have huge amount of features, and that some data is chosen as a test data and rest of data is chosen as a, we can say, training data set. We apply test data and remaining part is applied for the training data. In next iteration we change the training data. In next iteration we again change the training data, and we repeat this process, this iteration to the k times, and at the end we choose the best score model which is giving the best score in the test and training data set combinations. Okay, so it is a k-fold cross validation. I hope you understood. Any question? Any question in this k-fold test, k-fold cross validation? We select the model which having the higher score. At the end, we select the model which is having the higher score. That's it. Tell me, are you understood this concept? We also discuss a Python code. Also, we discuss for the k-fold cross validation. Don't worry. But any question right now? Tell me. Okay. So the next is stratified k-fold. So it is nothing but it is similar to the we can say k cross, or we can say k-fold cross validation, something like that. So we discuss is k-fold cross validation. So it is similar to the k-fold cross validation, but in every sample, it means previously we also taken the sample, but in every sample it also consider the target value. Target value, it means in the previous k-fold cross validation method, we don't consider the target value for the sampling, But in the case of this particular resampling method, we also consider during the sampling, we also consider the target value also. See this example. This diagram, see this diagram. In this diagram, we have, this is target value, targets class distribution, in which we require this type, this percentage of, suppose it is a 5% of female, and suppose rest of 95% are, we can say, male candidate, something like that. It's just an example. When we sample the data, for the test and rest for the training, then in the test data we sample the 5% are the female and 95% are the male per candidate. So we maintain the ratio of the target value of the sampling. So it is very important in scientific k-fold cross validation. So k-fold cross validation and these methods are totally equally similar, but the difference is that while during the sampling in each iteration we also consider the target ratio or the target value. Okay, that is the difference. So it is the first fold, then it is the second fold, third fold up to k-fold, and rest are the simply training set. So in each fold we maintain the ratio of the target value. So we consider the target value also. That's why it is the next variation of it. So then we simply read out the concept. So the process of stratified k-fold is similar to the k-fold cross validation, with one single point of difference is, unlike in the k-fold cross validation, the value of the target variable is taken. So it is very important. So during the sampling, we consider the value of target variable. It is taken into the consideration in the centrifugal k-fold methods. Okay. So it is also important. Please remember this concept, k-fold cross validation, and these methods are equally similar, but the difference is that only the, we can say, target variable is also taken. Then if for the instance the target variable is the categorical variable with the two classes. So in our example I am showing you there is a two classes, one is a male, another one is a female, and we have some percentage. So in the two classes, then the centrifugal k-fold ensure that the each test fold gets an equal ratio in the equally ratio which is given in the target of the two classes with compared to the training set. Okay, so we manage the ratio also. So here if it is a two classes, if we require the two classes in the case of target value, then we sample in equal ratio to the training set and the we can say test set data. So we maintain the target class attributes also. Okay, then this make the model evaluation and more accurate and model training less biased. Bias, it means if the value is going apart from the target value, then it is known as a biasing. Okay, so it is not biased. So it is best suited because we are considering the training variables also. It is the resampling techniques. We know very well what do you mean by resampling. We change if the test data and training data we change repeatedly in each iteration, then it is known as a resampling. So this makes the okay, it is the resampling techniques that creates the bootstrap sampling. Bootstrap, what do you mean by bootstrap? If you go to the concept of bootstrapping, so in the bootstrapping we changing the instances, we changing the instances, and repeatedly we change the in every instances. Suppose in a first instance, or we can say first iteration, we take one subset, and apart from that rest data is considered as a training data. In the next instance we take another set as a test data, and rest data is taken as a training data set. So it is known as a bootstrapping. So in the bootstrapping we changing the sampling data set, and at the end we consider all sample data performed value. Suppose in the first sample, what is the performance of the model? In the second sample, what is the performance of the model? And we choose the best suited value. So it is simply known as a bootstrapping. So it is very important concept also. Bootstrapping sampling. By the sampling data point from the original data with the replacement. Replacement, it means we same thing. We repeatedly replace the value of training set and test set during the each iteration. So this means that the bootstrapping sampling can be contain the multiple instances. No doubt we have k folds, so it have k instances of the same data point. Same data point, it means say we have same data set, and with same data set we divided in different types. One subset and a rest subset is known as a training data. And again in the next iteration, the next subset takes as the test data, and remaining is taken as the training data set. So it is having multiple instances, and we choose the best sample which is having near to the target value. So the model of trend on the bootstrap sample and evaluated on the all this data point that did not make it to the bootstrap sample. This is called the out of back samples. It means suppose there are some data which is not taking into the account that produce an effective result to the target value, that is simply known as the out of the back sample. So it is simple concept, don't need to understand if you don't able to get this point. But the important thing is that the stratified k-fold method is similar to the k-fold cross validation method, but the difference is that it also considering the target value during the sampling. That's it. That is very important topic. So it is an example. So it is the target value distribution. It is our data sample. We take in the target value, we take the test data sample as a equal ratio in the target value, and rest is known as a training data set, which is also in the equal value of the target value. So it is more accurate. The data is not biased because we are considering the target value also. Okay. Any question? Understood? Any question till now? Tell me. Get the idea about this method? Yes or no? Okay. Now, the next thing is probabilistic measurement. So I already told you in the we can say resampling, we only consider the performance of the model. In the resampling, we only consider the performance of the model. We don't consider the complexity of the model. But in the case of probabilistic measure, we also consider the probability, we can say performance of the model, as well as we also consider we can say this model complexity also consider in the case of probabilistic modeling. So reasoning is only checking the performance of the model, but it not consider the complexity of the model. So complexity is also very important. As I earlier told you, the linear regression contains the less complexity, but an artificial neural network contains the higher complexity. So probabilistic measures do not just take into the account the model performance, but also model complexity. So it also considers the model complexity as well as model performance. In the resampling, we consider only the performance of the model. Model complexity is measured of the model's ability to capture the variance in the data set. So what is the complexity? How much variance the data set is captured. I already discussed in the previous classes what is the variance. Okay, so what is the covariance and variance? What do you mean by that? So if the variance is maximum, so information is getting from the maximum variable, something like that. So it is very important. So how we can measure the complexity? By measuring the variance. If the variance is much large, then we can say it's little bit complex. So okay. So next, the first one is we can say alkyne information criterion, EIC, alkyne information criterion. So it is a first methods of probabilistic model selection method. So okay. Okay, so till now we are discussed what do you mean by evaluation of the model and what do you mean by selection of the model. Then we discussing the topic how we can select the model, and in the selection we have two things. One is the sampling and one is the we can say probabilistic. In the sampling, sampling it means a replacement. Then in that we simply discuss the two things. One is a K-fold and another is tenfold methods. This one, statistical K-fold cross validation, and that we can say normally K-fold cross validation. We discuss two methods, and then now we are discussing the probabilistic model selection. In that we first discuss today the alkyne information criterion (EIC) methods. Okay, so there is always some information. So this alkyne methods, what we do, we simply measure not only the information captured by the model, but how much information we can say skipped by the model. So model, how much information, less information captured by the model, or we can say suppose how much accuracy not captured by the model. Suppose we can say we construct the model which generate only 70% accuracy, then the skip part is we can say 30%. So what portion is not captured, that is measured during this we can say alkyne information criterion, that is simply known as the EIC. So let's discuss. So there is always some information loss which can be measured using the KL information matrix. So there is a matrix which is captured the information lost. How we can capture information lost is captured by using the KL information matrix. So Coulombic Liembler, it is the name of full form of the KL, or KL divergence is the measures of the difference, the probability distribution of two variables. So two variable probability distribution is captured by the KL, and that is simply measure the missing value, or which can be measured using the we can say loss value, loss information as loss by simply using the KL methods. So statistics Hirotigu Akai took into the consideration. It is one of the we can say statistics person who do this calculation. So it is it simply do with the help of KL methods and information likely look ahead value. Likely look ahead value, it means what is value we are currently considering and what value we are going to consider, how much percent, how much accuracy we require the model, and how it is computing, that much model we are computing likelihood value, and we check the how much information is lost. So took into the consideration the relationship between the KL information and maximum likelihood, KL information loss, and maximum likelihood, how much information we need to require for the model. So and develop the concept of information criterion or IC. So information criterion is simply considering with the two parameters. The one is a KL. KL information contains how much information is lost, and another thing is we can say likelihood, maximum likelihood value, maximum likelihood information which we require. So therefore alkyne IC EIC is measuring the information loss. Then simply we can say in one word, if you wish to say what is the EIC, alkyne information criterion, so it is nothing but it measuring the information loss by the model which we are going to develop. Sorry. So this is how to 1 minute. So this is how to discrepancy between the two different model capture and the model within the least information loss suggested as the model for choose. So with the help of EIC, if the information loss is very less, the EIC value is very less, then we choose that model. Okay, so we measure the information loss. If the information loss is less, then we choose that model. And how we can measure? By using this particular EIC method. So EIC method is measuring the information loss, but the past method are measuring the information performance. So it is the formula EIC is equals to 2k minus 2 of log L divided by n, where we can say k is the number of independent variables or predictors, how much variables are independent, and then the L is the maximum likelihood of the model, how much maximum likelihood of the model. Then N is the number of data points in the training data set, how much point we are considering for the training data set, especially helpful in the case of small data set. So if the data set is very small, then this method is very good. So what is the limitation? So the limitation of EIC is that it is not very good with the generalized model, as it tends to select the complex model that lose less training information. So it is not useful for the generalized information, because it's selecting the sample data and considering the information loss. So something is sometimes it's not good for the huge amount of data set. Okay. So today we simply discuss what is the model evaluation, and then we discuss what is the how we can select the model, and then we discuss there are two ways to selecting the model. One is the resampling and another is the probabilistic. In the resampling, we discuss the two methods, and in the probabilistic we discuss the one method, that is AIC, and in the next class we consider the remaining part. Okay, so any question, any doubt till now? Any question, any doubt? We discuss next portion in the next class. Okay. Okay, thank you very much.